This is 9-4. This is the lesson video. Your objective today is that you'll be able to complete the square to find vertex form. So to start off with, what we're going to be doing today is we're kind of going to be manipulating some equations so that then we can get things into vertex form, and it's just a little bit easier and kind of is nice. This is a good way to kind of be able to figure out how to go from like standard form to vertex form, which some people do find extremely helpful. So number one, we're starting off with saying, okay, if I have x squared minus 16x plus c, we're finding the value that completes the square. And when we're talking about completing the square, what we're looking for is we're looking for something that makes it so it's kind of, I guess the right word might be like perfect, where we can go x plus blah 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 or minus blah 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 squared. That's what the answer would be. And so one way that we can do this is by using the table method. So if I draw my table, and I can break this up. Okay, this x squared I know becomes x and x. That's just kind of what we've been dealing with a lot. What I want to put in here, in these other locations, is half of this 16. And so in this case, it's negative 8. And so if I go through this, I get x squared, I get negative 8x, negative 8x. This x squared is that. This 8, this 8 make that 16. The last thing that we have is this negative 8 times negative 8. With that, we get 64. And so 64 is what I'd like C to be. So I'd say C should be 64. Let's do another one. Let's do number 2. X squared minus x plus c. Make my table. X squared makes this an x and an x. Now this one's a little difficult because it just has this minus on there, and so it's really a minus 1, and we're going to divide it by 2, and that's actually what it winds up being, is negative 1/2 on each of these. And so I get x squared, negative 1/2 x, negative 1/2 x. This x squared makes that. This and this make that. And so that leaves me with negative 1/2 times negative 1/2. In this case, it's 1/4. So my c should equal 1/4. Okay. Number 3. X squared plus 7x plus c. And go ahead and you can pause this and try this on your own, see if you can do it. And you can go ahead and join us. I'll just be going kind of right here. Alright, x squared makes x and x, which makes x squared. I want half of this 7, so 7/2. And I'm actually just going to leave it like that because fractions are a lot easier to work with than people give them credit for. So this is 7/2x. This is 7/2x. 7/2 times 7/2 is 49/4. And so this is what I want my c to equal. Okay. All right, let's go on to number 4. It says complete the square for the expression, then factor the trinomial. So what we're going to be doing is pretty much the same, except we're going to kind of add another step onto there. Oops, that's number 4. So we have x squared minus 14x, and so we're going to make it so that we can factor the trinomial. We need to figure out what do I put in here to make it so that it works out nicely. And so I do the same steps as we just did. I have a box. I go x and x because that's x squared. I need to find half of this, which in this case is negative 7 and negative 7. This is negative 7x, negative 7x. Negative 7 times negative 7 is a 49. So what I'd want is I want this to be a plus 49. So now you want to write this, then factor it. This would be x minus 7 squared. And it is important to know that we kind of added on that 49. Let's look at number 5. X squared plus 30x. And we want to know, okay, what do we put in here? So I make my table. And making the table isn't necessary, especially if you start to get this. But it is kind of an easy way to see everything happening. I need to divide this by 2. So I get 15. That's a positive 15. So I get 15x, 15x. And 15 times 15 is 225. So I'd add on 225. Now I want to do and factor this, and it's just going to be x plus 15 squared. Number 6. X squared minus 9x. Go ahead and pause this and give it a shot. We're going to continue on. Alright. So I have x and x. That makes x squared. I have to find half of this, and so I'm just going to leave it as negative 9 over 2. So I get negative 9 over 2x, negative 9 over 2x, and then just on the side, 9 over 2 times 9 over 2 is 81 over 4. So 81 over 4. So I want this to be a plus 81 over 4. And so to factor it, x minus 9 over 2 squared. Okay. Now, you might have been going like, well, how can we do that? We're not supposed to be able to just like add numbers. And you're right. We're not able to just kind of add numbers into an equation. So if I look at number 7, where I have this, x squared plus 10x equals 16. So how this is a little different from what we were just doing is we have this equal sign in there. And so it means that we need to keep everything kind of balanced. And so one way that kind of some people like to look at this is they go, okay, x squared plus 10x plus some number equals 16. But we can't just randomly add some number, and so we need to add that some number to the other side. That way we're not really changing anything about it. And so we can use what we were just doing up above, where we kind of break this out, and we go, okay, I need to make x squared, which is x and x. And I need to make 10x, and I take half of that, and so it's a plus 5. And I plus 5. And so I get 5x and 5x, and that makes 10. 5 times 5 is 25. So what I need to do is I need to add in 25. But like we just said, we can't just arbitrarily do that. We need to do it to both sides. And so what I get is x squared plus 10x plus 25 equals 16 plus 25. And then going from that, we can factor this, and it turns into x plus 5 squared. Equals, I'm going to go ahead and combine this, 30, 41. Okay. And what we're doing is we're solving by completing, and then we're going to round our answers. So we're kind of at this point right now where I can now go, okay, do the square root, and we get x plus 5 equals plus or minus the square root of 41. Subtract 5 from both sides. And you get x equals negative 5 plus or minus the square root of 41. If you go ahead and plug that into a calculator, you're going to get x equals 1.40 and negative 11.40. Number 8. If I have x squared minus 3x equals 7. Alright. And so I go and I do my little box. So I do box, x and x, gets me x squared. I want to do half of this, so negative 3 over 2, negative 3 over 2. So it's negative 3 over 2x, negative 3 over 2x. This makes 9 over 4. So I'm going to add 9 over 4 to both sides. So I go x squared minus 3x plus 9 over 4 equals 7 plus 9 over 4. I can go ahead and factor this, and so I get that x plus, oops, not plus, minus, x minus 3 over 2 squared equals, this winds up being, it's actually easier if I just switch it all to this, so 37 over 4. Now I can start to solve. I do the square root, do the square root. I get x minus 3 over 2 equals the square root of 37 over 2, plus or minus. Then I add 3 over 2 to both sides, and I get x equals 3 over 2 plus or minus square root of 37 over 2. And if I used a calculator, I'd get that x equals negative 1.54 and 4.54. Number 9. X squared plus 15x equals 12. Now, you might have started to figure out kind of the pattern that's going on here, and you might not need to be doing the square, that square box, the table method, in order to make this happen. And that's totally fine. And if you haven't caught on to it yet, what we do is we take this value here and we divide it by 2. So we go 15 divided by 2, and then we square it. And we plug it in both here and here. And they're always going to be a positive value. And so in this case, we can rewrite this as x squared plus 15x plus 56.25 equals 12 plus 56.25. Well, this is going to be x plus 7.5 squared. That's going to equal 68.25. Do the square root. Do the square root. We get x plus 7.5 equals plus or minus. This winds up being 8.26. Subtract 7.5. And we get x equals, this winds up being negative 15.7 0.76 and 0.76. Okay. Let's do number 10. X squared plus 22x plus 25 equals 0. Okay, so how this one's a little bit different is we don't have anything on the right-hand side, and we have a value for c. It's always worth checking and making sure that it doesn't work before you just try and I'm just going to make this happen. So in this case, it doesn't, and so I go, okay, minus 25 from both sides. And so I get x squared plus 22x plus some number equals negative 25 plus some number. I'm going to go ahead and I do 22 divided by 2, which is 11, squared, which is 121. So I'm writing in 121 for both of these. And so I get x plus 11 squared equals 96. Oops. I do the square root of 96, and I get x plus 11 equals plus or minus the square root of 96, plus or minus the square root of 96. Going to subtract 11, and so I get x equals negative 11 plus the square root of 96. So I get negative 1.20, and if I do minus, I get negative 20.8. 20.8. All right. Number 11. If I have x squared minus 10x plus 17 equals 0, I subtract 17 from both sides. I get x squared minus 10x plus blank equals negative 17 plus some number. 10 divided by 2 is 5, squared is 25. And so I get x minus 5 squared equals 8. Do the square root, do the square root. X minus 5 equals plus or minus the square root of 8. Add 5 to both sides. You get x equals 5 plus or minus the square root of 8. And that winds up being 7.83 and 2.17. Okay. Alright, number 12. So we have 3 x squared, oops, put that in parentheses, 3x squared minus 15x plus 27 equals 0. And so I take the same steps. And the where this is a little different is that we have this 3 in there. And so what we can do is we can kind of start to manipulate it right off the bat, where I subtract 27 from both sides. And I get 3x squared minus 15x equals negative 27. I'm not going to add something in here. But what's a little different is that we have this 3 here. And so what I'm going to do is I'm going to factor out that 3. And so I get x squared minus 5x plus some number is going to equal negative 27. And I do the same thing where I go, I do 5 over 2 squared. Because I'm kind of looking just inside of this parenthesis whenever I'm doing this. So I do 5 over 2 squared, which gives me 25 over 4. But when I do that, when I go to the other side, I don't just do just this 25 over 4. I have to take that 25 over 4 and multiply it by 3. And so I get 75 over 4. And so as I continue through this, I go 3 is x minus 25 over 4 is, we can reduce this down to 2.5 squared. We don't really need to worry about the 25 over 4. It's just this 5 over 2, which is 2.5. That squared equals 27 plus 75 over 4 is negative 8.25. Divide both sides by 3. And we get x minus 2.5 squared equals, it equals, I think, oh man, negative 8.25 divided by 3, negative 2.75. Negative 2.75. If I do the square root, oh, we just hit one of those imaginary numbers. And so the square root of negative 2.75, we have no solution. Alright, number 13. 2x squared plus 40x plus 32 equals 0. I subtract 32 from both sides. Get 2x squared plus 40x equals negative 32. Factor out this 2 plus 20x plus some number equals negative 32 plus some number. Looking on the inside, we do 20 divided by 2 squared. 20 divided by 2 is 10. 10 squared is 100. To do it to this other side, we have to multiply the 100 times 2, so this is actually plus 200. And so I get x plus 10 squared equals 168. This has a 2 on the outside. Divide both sides by 2. And I get x plus 10 squared equals, that winds up being 84. Square root both sides. I get x plus 10 equals, I'm just going to leave this as the square root of 84 for right now because we're evaluating it, plus or minus. Subtract 10 from both sides. So I get x equals negative 10 plus or minus the square root of 84. So I get x equals 0.83 and negative 19.17. Okay. Number 14, a little different. Find all values of b for which x squared plus bx plus 49 is a perfect square. And so what I do is I take 49 and I do the square root of it, and I get plus or minus 14. Or no, not 14, 7. Plus or minus 7. There we go. Getting ahead of myself. And so my b values are double this. So I multiply that by 2, and so my b values are negative 14 and 14. Okay. Oops. Number 15. We need to determine whether the quadratic function has a maximum or minimum value. Then find the value. So y equals x squared minus 6x plus 4. And so whenever we have it like this, where we don't necessarily have a 0 on the other side, we can still use this with completing the square in order to kind of find where our stuff is at. So the way we could do that is we could subtract 4 from both sides, and I get y minus 4 equals x squared minus 6x. And then we do the same thing, where we do negative 6 over 2 squared. In this case, 6 over 2 is 3, 3 squared is 9, so I add 9 to both sides. And so I get y, negative 4 plus 9 is positive 5, equals, this is x minus 3 squared. If I subtract 5 from both sides, I get y equals x minus 3 squared minus 5. From that, we can figure, this is in vertex form right here. And so our vertex is 3 comma negative 5. If I look at my graph, or at my equation, I can kind of look at the very beginning. I can even say, oh, it's kind of normal, it should be going up. And so that tells me this is a minimum, and the minimum is at negative 5 because it's the y value of our vertex. If I do 16, y equals 2 x squared minus 16x minus 7. Same thing, add 7 to both sides. So I got y plus 7 equals 2x squared minus 16x. I factor out the 2 x squared minus 8x. We're going to have some number that we add in there. I go negative 8 divided by 2 squared. 8 divided by 2 is 4, times, or squared is 16. So y equal, or y, not equals, y plus 23 equals, oops, not 23, it's not 16 either. And the reason why is it's kind of one of those things that's really easy to do, is whenever you have it inside of one of these multiplications, you actually have to multiply by it. So it's 16 times 2, which is actually 32. And so y plus 39 equals 2x plus, or not plus 4, x minus, oh, this was a plus, that's why I messed it up. Okay, x plus 4 squared. I subtract 39. I get y equals 2 x plus 4 squared minus 39. That tells me that my vertex is at negative 4 comma negative 39. So if I look at my very beginning it's positive, so it's normal. So I have a minimum at negative 39. 17. Y equals negative 3x squared minus 15x minus 21. I add 21 to both sides. So y plus 21 equals negative 3x squared minus 15x. Factor out that negative 3. So y plus 21 equals negative 3. X squared plus 5x. So I do 5 over 2 squared, which is 25 over 4, which is about 6.25. When I take it to the other side, I need to go 6.25 times negative 3, which is negative 18.75. So I get y plus 2.25 equals negative 3 x plus 5 over 2 is 2.5 squared. Then I subtract 2.25. So my y equals negative 3 x plus 2.5 minus 2.25. This negative tells me that it opens down, so that means I have a maximum at, my vertex, I guess I should tell you that, is negative 2.5, negative 2.25. So my maximum is at negative 2.25. Do one more. Y equals 5x squared minus 20x plus 25. Subtract the 25 from both sides. Y minus 25 equals 5x squared minus 20x. Factor out the 5, so y minus 25 equals 5x squared minus 4x plus, we're going to add something on, so negative 4 divided by 2 squared. Negative 4 divided by 2 is 2. 2 squared is 4. But when I move it over here, I have to multiply it by 5. So 4 times 5 is 20. And so I get y minus 5 equals 5 x squared, x plus 2 squared. Or no, in this case it's minus 2, isn't it? Because it's negative 4 divided by 2. So x minus 2 squared. Add 5 to both sides, and you get y equals 5x minus 2 squared plus 5. So my vertex is at positive 2, comma 5. And so my graph is upright, so it's a minimum at 5. And that takes care of everything. Check with your teacher on your assignment. Have a good one.